Welcome back for part 2 of this join module. In this lesson, we're going to learn how to write a join in Google BigQuery. So when we say syntax encoding, that always means just how do you write it? What is the structure for the code? Taking a look at our outline, we've already completed part 1, joins, and now we are in part 2, our join syntax. There are different types of joins. I alluded to this a little bit in the previous lesson. We're going to focus on our inner and our left join, but there's also things called right and outer joins. Joins require a description of how the tables are connected. So in the last lesson, we talked about how the appointment type is what connected two tables. Whenever you're doing a join, you need to know ahead of time, how do these two tables relate? What column or multiple columns make a connection from my from table to my join table? You specify which columns are connected using either an on or a using statement. They're a little bit different, but you can always use an on statement. A tip is that you always create an alias for any tables that you're joining. And the reason why is that when you use the on statement, you have to say my from table column equals my join table column. And if you don't have an alias, it just gets really crazy. The code gets really crazy. So I would say creating an alias as like a rule, not a suggestion. You always want to specify the level of your data before joining. This is something that's a little bit more of an advanced topic in terms of joins. What we're going to do for now is we're going to keep it really, really simple, but in a couple modules looking ahead, we're going to go into more detail on this. So don't worry about it too much now. We're just going to keep it simple and then we'll start adding to it. So let's look at our order of operations. Step 1, you want to identify what tables am I joining? Which one's going to be my primary? Which one's going to be my secondary? If you remember from our last lesson, our primary table, we want that to be the table that has more data, more columns and rows, and the secondary to be the smaller one. If they're about the same size, then it doesn't really matter. Step 2, identify the level of each table. So the level being what is this row telling me? In example, with our taxi cab data, each row, it's at the individual trip level. Step 3, what type of join do you want to do? A left join or an inner join? And step 4, you want to sort your query by level from big to small to verify that the join worked correctly. And so this is a tip that we'll go over in the example. And this is just something to help to say, okay, did the join work exactly like I wanted it to, or did something go crazy? So this is the syntax, and you'll notice a couple of things. First, you'll see that we're using aliases, not only for the names, but we see for the New York City bike trips, we're calling that bikes. And then we have this new table called city bike stations, and we're calling it stat for station. You'll see here, we're invoking our dot notation. We've used the dot notation before when we were using CTEs, when we do like base.star or something like that. Here, what we're telling Google BigQuery is that I want my bikes start time data. I want my bikes region data, bikes start station ID, but then down here, I want the stat or the station name, and I want the station capacity. So this lets BigQuery know which column comes from which table for the final output. You'll notice that we have station name from bikes and station name from our station table. My suggestion when you're first starting out is just go ahead and pull any of the columns that you're joining on just so you can kind of see it and look at it. Once you have it under your belt, this is redundant and I wouldn't recommend, but when you're first starting out, I think this is a good technique. Okay, let's open up the BigQuery console and I have a practice problem for us to work through. Okay, so our practice problem, it looks like it's a lot of steps, but I really just wanted to outline line by line what we'd be doing for the join. So we have our two tables. One is our city bike trips data. We've been using that in a couple of the examples, so we're pretty familiar with it. We're now introducing a new table called city bike station data. And what this has is it has a couple of extra data points on a particular bike station, and we'll look at that in a moment. So for part 1, what we're going to do is we're going to find all the trips that occurred by station in the city bike trips for May 1st, 2014. We're going to select the year, month, day, start station ID, and station name. And then we're going to find the total number of trips. So we'll do a count star. And then after that, we're going to identify the level of data for this query. Okay, once we do that, we're going to put that to the side. Then we're going to review our city bike station data. We're going to select the region ID, station name, and capacity. And then we're going to identify the level of data for this query. Once we have that and we verified what's the level of data for my query 1, my query 2, then we're going to identify which columns match between these two. We'll put query 1 in a CTE, we'll call it trips. We'll put query 2 in another CTE and call it stations. And then we'll join our trips to our station CTE, so the ones we just made in step 4, joining on our column that we identified in part 3. And then for the last part, we're going to calculate how many turns each station had. And so what I'm calling a turn is the number of times all bikes were rented out for a given day. And then we'll order the final query by station capacity and the number of turns. Okay, let's get started. So let's open up. I'm just going to copy part 1. Station and city bikes for May 1st. So since we've done this query a few times, I'm not going to go into like a lot of detail. I'm just going to write it out. So we're going to do select, extract year from start time as year, extract month from start time as month, extract day from start time as day, and then we want start station ID, and then start station name from our table where the date of start time equals May 1st, 2014. Oh, I have a problem because my date time should be year, month, day. Yep, okay, great. So let's start with that. Oh, and then we want to find all the trips. So we know that this data, each row counts as one trip. So that's easy enough. All I have to do is a count star as total trips, and then apply my group by. Because remember, anytime we evoke an aggregate function like a count, sum, average, max, or min, everyone has a role at the party. Either you're getting grouped or you're being aggregated. Since count is being aggregated, columns 1, 2, 3, 4, and 5 must be grouped. Okay, and let's run it. Okay, so I see that I have 325 rows. Okay, so what is the level of this data? Looking at it, we have time component, year, month, day, station, and then total number of trips. If I look at this, there's only going to be one station per row. So this data is at the day, well, we'll put time station level. And how do I know that? Because each row, what does this represent? This represents how many trips a given station had on a particular day. So that's the level of this data. Okay, now that we've done that, let's take a look at part 2. We're going to be using our station data. And this is new, so we're going to take a little bit more time with this one. Let's take a look. So looking at this, I see I have a station ID, a name, a short name, which looks like it's something for a computer, not for human eyes. We have a latitude, longitude, region ID, rental methods, capacity, number of bikes available, number of bikes disabled, number of docks, and then some other things, some true and false, if it is returning, if it's renting, if it's installed, and then it looks like we have a reporting time. When was this last captured? And I look at it and I see that I have 2,209. My first thought looking at this data is that is this telling me what the capacity is for a particular station over time? So I have West 25th Street and 6th Ave. This time says 1970s. That's probably bad data. But does this mean that over time I'll see him each time, like every day? Like, what's the capacity at noon? What's the capacity at 4? Things like that. So I don't know yet. So the first thing I'm going to do is I'm going to explore that hunch. And let's look at the Bessie state and church state, because his date, oh no, let's look at row 3. Because I want to look at someone who has a correct date. 1970 date is wrong because this didn't exist at that time. So let's do select star, where name equals, and we'll just do a little copy paste here. Okay, so I see that I only have 1 row per station, so that kind of debunks that. But maybe it's just that this particular one doesn't have it. So how can I find a way to see how many times does a given station occur in the data set? So how I could do it, I could do name. So give me all the names and then count how many times the name occurs. Number of occurrence. From stations, group by 1, order by number of occurrence, and I want, if you have more than 1, to be at the top. So we're going to do order by number of occurrence descending. Okay, so looking at this, I can see that each station only occurs 1 time. So what does that mean? I can deduce at this point, I can deduce that this table, City Bike Station, is at the station level. Table is at the station level. I know that because in each row, the station is only represented 1 time. And then all of this other information is just telling me about this particular station. So what is its latitude, longitude, what is its region, the number of capacity, how many bikes can it hold, and a bunch of other things. Okay, now that I have that, now that I know the station level, I guess that's 2B, let's do 2A. So we want region ID, station name, and capacity. And I believe station name is just called name. Okay, so let's run it. Okay, so now we have our query 1 and our query 2. Let's look at these side by side. So here are my 2 pieces. I have my part 1 and I have my part 2. Looking at the number of rows, it looks like part 2, he's the bigger guy. He has 2,200 rows, and part 1, he only has 325. However, if I look at, this is filtered for a particular date. If I look at the entirety of this table, he has 58 million rows. So my trips data is actually much bigger than my stations data. So if I look at my stations data, it has 2,200. So I'm going to make my part 1, he's going to be in the from, and then part 2, he's going to be the join. And this is just being like a little nitpicky. If you flip these around, the information would be exactly the same, and we'll do that, but this is just best practice. So smaller table will be in join. Bigger table will be in from. Okay, so looking at these, I have station ID, and I have station name, and then I have station ID, and then the name, which is also the station name. Looking at these, you might be tempted to say, well, I'm going to join on the start station ID. But when I'm looking at this data, these do not match, not even close. This start station ID, this kind of looks like something a computer generated, like a special password or something for each station name. And then when I look over at my trips data, this looks like a proper station name that someone at a company might have. Oh, station 262 is not working well. They wouldn't say station this. They would say something reasonable. So that doesn't look like that's going to be a very promising join for us. However, if I look at the name, these names look kind of similar. And let's see if they share any. So I can say where name equals okay, so I can see that in my trips data, I have Watt Station or Watt Street and Greenwich Street, and it had 77 trips on that day. And then I look at the capacity, I see that same station, it has a capacity of 35 bikes. So the name, this looks like this is the column that we need to be joining on. Okay, so let's flip back. Okay, so we did 1 to identify which columns match between query 1 and query 2. Station, start, station name, and name. Okay, step 4. So we have step 1 here, and we're going to be dropping step 1 and step 2 in a CTE. So we're going to say with, what did we call it? Trips as query 1. Comma. Let's see, stations as query 2. And this is my query 2. This is getting a little cluttered, so I'm going to get rid of this part. Okay. So put query 1 in a CTE, call it trips. Put query 2 in a CTE and call it stations. Done. Okay. 5, join trips to stations joining on our similar column. Our similar column is station name and name. Oh, and let's get rid of this one. Okay. So we're going to do select star, select all the columns from everything that I'm doing. From, trips, inner join, stations. Now you might say, hey, why didn't you do an alias? These are already aliased. I'm not doing like this whole BigQuery public data thing. It's a reasonable name, so we can leave that. Okay, how do these two tables connect? As soon as I do this, I get this error code. Inner join must immediately following on or using clause. It's saying that you cannot just say join without specifying how they're connected. How are these connected? They're connected by trips.start station name equals stations.name. Forgot my on. On equals trips.start station name equals station.name. What am I saying? I'm saying, hey, BigQuery, give me all of the columns of my trips and my stations, and these tables are connected where my station's name is equal to my trips start station name. These are the connecting columns. Let's see. Sorry, it's not on equals, it's just on. Okay, we'll run. Okay, and let's see. So I see that I have year, month, day, start station ID, start station name, total trips. This is the left part, or this is the from, right? This is our trip data. And then immediately after, then it goes into our station data, region ID, station ID, name, and capacity. And looking at these, you can see East 19th Street and 3rd Ave, our start station name, is equal to our station name, East 19th Street and 3rd Ave. And then we have the capacity. something I want you to note is that our trips data had 325 stations. After doing the join, we have 244 rows. What does that mean? That means that when I performed the inner join, they didn't have complete perfect matching. So if you remember back to our vet data, how like ear cleaning or the teeth cleaning didn't make it in because it wasn't in both the tables, that means, we'll put a note, there are some stations that are in our trips data, but not in our stations data. So if you're joining on what is called text data or strings, BigQuery is very particular about this. If this was all uppercase, that would not be the same thing as it is with the camel case. So something that we could do to try to troubleshoot to see, is there a way we can make our join a little fancier so that we could get more? We could try doing, let's make both of these all uppercase and then try the join again. And this might help us, it might not. In general, it's good practice to just always apply the upper anyway, because if someone enters in a station and then they put in a weird type of case, then you don't have to worry about it because you've already put in this error handling having the upper already there. So let's try again. Nope, we have the 244. So what does that mean? That means that whatever stations that are in the city bike trips, they're not in the station data. Maybe it's a station that got closed down. Maybe it's a station they don't want to record anymore. Who knows? Maybe they changed the name and it's in here for 2014, but it's not in this table over here. Okay, we can get into the debugging on that at another time. But now what we're going to do is we are going to calculate the turns at each station. So a turn is the number of times all bikes are rented out for a given day. And the next thing I'm going to do is, because these are too many columns for me to look at, so I just want to do trips.star, comma, stations.capacity. And that's really all I need, right? Because I want my trips and I want my capacity. And the region ID, it looks like it's 71 for all of them, so it's not a very helpful column. So let's run it again. Okay, much easier. So we have our year, month, day. We have our start station ID, the name, total trips, capacity. So what I want to do is I want to say, okay, Broadway and West 53rd Street, they had 132 trips on this day, and their total capacity was 85 bikes. So they turned one full revolution of bikes. They did 85 bikes plus whatever the remainder is. So let's pull out our 85 divided by, 132 divided by 85. That would give me 1.5. And I just did that on my phone very quickly. I'm still getting used to this Mac. We're going to do safe divide. We always do safe divide instead of regular divide so we don't have to worry about errors in the future. Safe divide total trips, comma, capacity as turns. Okay, safe divide. So we're going to take these total trips, 132, divide it by 85, and our new column would give us a value of about 1.55. And what we're saying is that that whole bike rack, it turned one full time plus another half. And then we're going to do that for every single row. So let's try. Control Enter. And here we go. So we have, it's a different order from before. So let's do this. Order by turns. How did I want it? Order by station capacity, then number of turns. Order by capacity, and then turns. You'll notice that capacity is highlighted as blue. That's because that's actually a keyword in BigQuery, so it's not good practice that we named it capacity, but we'll let it slide for now. And we have capacity going from small to big. Let's do it decreasing, because I think that's more interesting. I'm seeing that these ones that have these big capacities, they're not really hitting full turns. This guy, West Street and Chambers, he he's very popular, right? Because I'm looking, he has a lot of bikes and they all rented out almost twice. Same thing with Broadway and East 14th Street. Lafayette, they're at 3 almost. That's really high. So why did I sort it like this? Because if I was a data analyst and they said, Candace, we need to put more bikes somewhere, what I would do is I'd probably look at this and see what are my areas that are having like a lot of bikes, like this guy here at FDR Drive and East 35th Street. They have a lot of bikes, but they're not even renting them all out in a given day. I'd probably want to take away some of his bikes and then go to someone who is a little bit higher up, maybe East 17th Street and Broadway, who every bike gets rented out 3.5 times, and I'd give him some more bikes. Okay, so now we've done all this, let's jump back to the PowerPoint and wrap up. In today's lesson, we learned about the join syntax. We walked through an example performing a join. While we did that, we also practiced our group by, our where, our order by, and our CTEs. Following lesson, you're going to have a chance to practice a simple join, very similar to this problem, on your own. And then as we go through the course, we're going to start layering in some additional complexities to joins and then also introducing the left join. See you there.